Hi everyone, welcome to our channel Code with Sunny, and today I am going to discuss the solution of the problem letter case permutation. 784 is its index and problem is of medium type. Okay, so basically we have been given a string S and we can transform every letter individually to lowercase or uppercase to create another string. Okay, so we have to return a list of all possible strings we can create. Okay, and our output can be in any order. Okay, so let's understand this deeply what the question says. Okay, so let's move on to the example. So suppose we have been given a string as a1 b2. Okay, note that the first character that is at index 0, the character is small a. So the question says that we have to convert every letter to either to lowercase or to uppercase. Okay, so a small a can be converted to capital A, or it is left as it is. Okay, so you can see if it is left as it is, our new string would be a1 b2 as it is, and if it is converted to capital A, so our new string would be, let me write here, that is our new string would be a1 and small b2. Note that after moving to some increasing index, we found that there is another character small b. If small b is left as it is, then our new character, that is new string, would be what, a1 b2, and if small b is changed to capital B, then our new string would be a1 and capital B and 2. So there are total what, four possible strings. What are the possible strings? Small a1 b2 and small a1 capital B2 and capital A1 small b2 and capital A1 b2. So basically we have to recurse and find out what are the total possible number of distinct strings that we can make, either to convert a current character to its any other case. That is, suppose the current character is of lower case of type, then we can convert this character to uppercase, or left as it is, or we can convert to the current character to what, to uppercase, and then move on to the next character and perform the same operation. So what would be the maximum number of distinct strings that we can get? Now, how to handle the case of character efficiently? Note that we have a function inbuilt is alpha. What is this function doing? Checks, let me write, checks, okay, checks if the character is so is alpha is going to check if the character is lying bit in the range small a to small z, or the character is going to lie between capital A to capital Z. Okay, so if the our character is lying in between this range or this range, note that we have to convert its case to its other case. Suppose the character is lying in this case, then we have to convert to uppercase, and if the character is lying to uppercase, then we are going to convert to its lower case. Now how to perform the toggling case efficiently? Okay, so let me introduce you with another good concept, that is, suppose our current character, let's say ch, is what, let's say we have a. So if ch is a, then ASCII value of this character is 65. Okay, let me write 65. Now one thing you can notice that if we write the binary representation of 65, then you can notice that it would be like 64. I am writing the values. Okay, 64 plus 1. So if any values, that is for character capital A to character capital Z, I am going to write this also. Okay, to ch equals capital Z. Okay, I'm okay. Now ch equal to capital Z. Now for this, the capital Z, you can also notice that its ASCII value is actually, let me write, capital Z equals what, around 90, or yes, I guess capital Z would be what, 91. Okay, okay, let's leave that, it doesn't matter. So I'm going to tell with capital, or you can say we have ch equals to a, or we have, let's say, ch equals to what, let's say c. Now for ch equals to c, its ASCII value would be what, 65, 66, 67. Again you can notice that our this combination with 64 plus 2 plus 1. Okay, so again you can notice that there isn't a 32 that will come. 32 would be what, power of 2, that is 2 power 5. 32 would not come from character capital A to character capital Z. So, and also for character, let me write, for character equals A to character equals Z, 32, that is actually a what, power of 2 comma 5, will always come as a part in its binary representation. So suppose I am going to take A, then it would be what, 97. So 97 can be written as 64 plus 32, that is what, 96, and we are going to one add 1 again. So you note that 32 is always come. So one thing to convert capital case to its lower case is to add 32. We can do by doing the XOR with 32, and if to convert small a to its capital A, or to a smaller lower case character to a capital case character, we can again take the value, that is take XOR with 32, it would give the capital case character. So I am going to write, let us say we have a string str equals, suppose, let's say we have a character, let's say we have a what, Sunny. Okay, suppose I have to convert this s of 0 to its smaller case. So what I am going to do is I am going to take XOR with what, 32. 32 is basically 1 less than 5. This is what actually a left shift operator. This would convert our new string, would be s equals what, this. So and and this would satisfy also if we have to convert smaller case to uppercase, we have to do the same thing. Okay, so what would be our approach in this problem? What I am going to do is to use backtracking and consider every possible state of the string. So at any case where there are two possible states. What are the two possible states? I am going to write, let's say, either, let me say, convert, okay, I'm going to write convert the character to its another case, that is if it's lower convert it to upper, or upper to convert it to lower, or left the case of the character as it is and go to its next index. So either left the character as it is and go proceed for next index, or to convert the character to its another case and then proceed to the next index. This would be our approach. Okay, basically we are using a backtracking along with recursion. So let's move on to the solution, to the code of this problem. So what I am going to do is I am going to make my answer, which is of vector of strings. Now I am going to call the solve function, which is basically backtracking. I am calling to backtrack every possible case, that is to consider every possible states of the string. I am passing the current string state and index 0, starting with index 0. Now in our solve function, if index reaches the length, then I am going to push back my answer as to my vector of strings. That would be our answer, and I am going to return as it is, because further processing of the string can't be done because we have reached the maximum index. Now there are two states. I am going to move to the next state, that is go to index plus 1 directly without changing the case, or if the case, that is if the current character case can be changed, that is our current character would lie between small a to small z, or to capital A to capital Z, then I am going to change its case, and it is going to be determined by is alpha function. So is alpha returns true if our current character case can be changed. So if this is going to return true, what I am going to do, I am going to change the index of the current character by taking XOR with 32, and I am going to call our again solve function to move to our next string. I am going to pass s and move to our next index after what, after taking XOR with 32. This would consider all the possible case, and our answer would be stored in vector of strings. That would be our answer. Okay, so the code becomes easy using backtracking. Note that why I am using backtracking, because you can consider, you can see our string length can vary up to 12. So maximum possible states would be 2 power 12. So it would be roughly around 1024 into 4, which is very small amount. So we can consider we can use the backtracking or recursion, you can say. So let me submit this code and check out. Yes, it is correct. Okay, so if you have any doubts, do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this video.